Hi guys, good afternoon. I'm so sorry, I apologize for the delay. My sincere apologies. It was due to a technical problem. I really apologize for that. I don't know if you guys can hear me. Please, if you can hear me, kindly indicate that you can hear me.
Yes, go on, can hear you.
Okay, so my name is Ibukwe Success, Junior Data Scientist in Harmony. Welcome to 2023. Happy New Year, guys. This is the very first live coding section in this new year. So thank you guys for joining. I appreciate your presence. So before we start, I have to first of all share my screen so that we can start ASAP. So can you all see my screen?
Yes.
Okay, so our topic today is data storytelling in pattern recognition. Okay, so we're going to talk about what are outliers. Outliers are those data points which differ significantly from other observations present in a given data set. So how the outliers are introduced in data sets. Most times the outliers, happen to be through data entry error. This error occurs as a result of human error during data collections. It's also, it happens through measurement error. This error occurs as a result of instrument error. Is the most common source of outliers. You know, it happens when the measurement instrument used is faulty. So how to detect these outliers? You can detect outliers through a hypothesis testing, Z-score method, percentile, standard deviation, data visualization. But in this particular presentation, we'll be using data visualization to identify our outliers. So I kind of explained briefly about EDA, exploratory data analysis, which is the process of examining the available data set to discover patterns, spot anomalies, test hypotheses, and check assumptions using statistical measures. So I started by installing Scitable, installing the libraries I want to use for this particular. So I imported the necessary libraries for this particular presentation. So wait for the installation to happen before we run our libraries. Okay, yes, also successfully imported our libraries. So this is the data set I'm using, data food index.csv. So we're going to use bd.read underscore CSV to read the data set and call it into. So as we've done that, we'll check the head of the data set. So this is the data sets, and these are the columns. You can see column name, country name, country code, 1990 to 2000 to 2012 to 2013. So looking at this, you just realize that the way the columns are appearing, especially the ones that have numbers under them, it's not appropriate. You have to use you have to clean up the data. You need to remove this double names on each column. So later I'll show you how I was able to do that. So we'll go ahead to check the information on the data set. So you will see that we have some, you can see we have about 271 entries of the data of the rows. Then you can see the data type, they are all in objects. So let's move ahead to see the shape of the data set. Let's see, we have about 271 rows and 14 columns. When you check the data types, you see that all of them are in objects. Even though the one that has numerical values are in object. I know that is not good. We're going to convert it soon to float so we can be able to visualize our data set. So move ahead to check the df.columns. Remember when I told you about 2012 having double names in each column, which is not appropriate? You're supposed to have, like, want it to be in 1990 only, without having 1990 square brackets, without having a double name, and without having we don't want to have these YR attached to our column. So what we're going to do is we use replace function to replace the column. So what I did here, I said df equals to clean underscore headers df comma replace equals to the dictionary this bracket here, going to say YR 1990 semicolon. Then we're saying where you have YR here 1990, replace it with nothing. Replace it with nothing. Where you have YR, replace it with nothing. So if you run this, you can see that this particular function we did here has done 100% cleaning on the data set. Do you understand? So it has done 100% cleaning on the data set, and it leaves. So we want to see what it did. So when we run this, we see that it's actually done justice to 1990 column, but it left the other columns still looking somehow. You understand? So I figured that in order to clear other errors in the other columns, I defined a function to do that. So what I now did, column underscore list equals to, I listed all those columns that has all those malfunction. So what I did, I listed the things I want to displace, the things I want to remove out of the data set. So I did 200 underscore year, 2012 underscore year, 2013 underscore year, and so on and so forth. So for column in column underscore list, df equals to, using the same function, clean underscore headers, df replace equals to f, replace the column with nothing. So when you run this, so one good thing about this function, it will show you how far it has gone. So you can see that each column has been properly cleaned. The work has been done. you can see 77.4% work has been done on each column. So when I check the DF, so we can see df.column, we can see that all the columns have been, they are now in order. So I have my 1990 standing alone, 2000 standing alone, 2012, 2013, 2014, 2015, 2016. Standing alone. So that makes it very cool. So when I run this, you'll see that that change has been effected. So moving forward, EF type. So I want to check the DF type. So I can see that the change, this function I ran here right now. I just wanted to confirm that, I've done the change has been effected. So I'll move over here to check. So right now, when I see my data set, I can see I have some null values and I have some dotted values in my data set, and it's not supposed to be. All I want are columns with, all I want is columns with variable numerical values. I don't want noun values. I don't want all these dotted values under my columns. So what I would do is that I would say, okay, df dot replace all the dotted values, replace it with np.nan. So in place equals to true. So when I run this now, it has done. So I will now check the number of dotted values in, just to know if it has gone out. So I will now say, okay, the null values has all disappeared because of this function I ran here. So when I run this, I will see that those dotted empty strings, right, they have been replaced with non-values. So when I go back, moving forward, I will now say, okay, since I now have my non-values, okay, what's the next thing to do? I have to use a function drop NA. So I will now be like, I want to drop all the non-values in my data set. So if I drop this and I check the DF, you see all the non-values have all been dropped efficiently. So I will have to check if there are still non-values. You can see there are no non-values. Each column registered 0 non-values. So moving forward to checking my idea. So remember when I told you guys that some of my columns are in, they are in float, they are in objects. Like when you type D types, you can see that some of my columns are in object form, and I want them to be in float. I want them to be converted to float so that I can be able to plot, can be able to visualize the data set. So doing that now, I use this master type function to convert the columns that has objects, converting them to float. So when I run this, and when you check the D types, you can see they have some of the columns that have the object D type, they've all been converted to float. You can see 1990 is now in float, 64, they're all in float format instead of object. So moving ahead to do the visualization. So what I did here is I checked the food production in different countries in 2017. Like this particular graph here is trying to explain the food production in different countries in 2017. So from this particular graph, line plots, you can see that BHR had the highest number of food production compared to AFG. So let's just quickly check the country without BHR. This is like the code of the country we want to check. By doing that, let me just you can't really be able to see that now. Well, but let's just know that looking at this line graph, you see that the BHR had higher number of food production in 2017. And this could actually vary in different years because BHR might have a very high number of food production in 2017, but in 1990, maybe they might have a lower number of food production. So this particular presentation we're doing, this particular live coding is to explain the pattern of food production in different years. Okay, you try to say, okay, this country had very minimal number of food production in 1990, but in 2017, their food production increased. Okay, so later on, I'm going to show you a line graph that has all the years put together, so that you see how each country had a change in food production as the years went by. I don't know if you're understanding me. So moving forward, let me run this. So okay, this particular describe function, I just wanted to take the statistical information of our data sets. So you see the counts in the mean, the STD, the minimum number, the 25% percentile, the 50% percentile, 75% and maximum. So moving forward, let's wait for this to run. So this is food production in 1990. 1990 food production in different countries. So you can see that from this graph here, let's check this particular. So we have FGI having the highest number of food production in 1990. So that particular country that had the higher number of food production, BHR, let's check it in 1990. Let's see how their food production was in 1990. I don't know if this data was able to capture BHR. Okay, it wasn't able to capture it. So let's just check. This is FGI. So let's compare the FGI. So let's just move forward. I'll show you a better visualization later, so I can be able to understand the pattern. So this is another food production in 2000. So when you look at this particular graph now, you see that the ATG had the highest number of food production in 2000. While FGI had the highest number of food production in 1990. So as you can see how the post office, the pattern is going. So it is not consistent. So when you check, okay, this is ATG now. When you go over to the other visualization, let's check AGD. AGD. You can see that AGD had what is one of the best country that had the highest number of production, but it wasn't the highest. It wasn't the highest in production. It was FGI that was the highest in production. So let's move on to the next visualization. So this is food production in 2020. So looking at the food production in 2020, you can see that this is Hong Kong. Hong Kong had the highest number of food production in 2020. But when you check Hong Kong in other years, you will see that Hong Kong had, it wasn't the best, but the food production is not as high as it is in 2020. So moving on. So I try to check all the food production in all the years, so I can be able to compare the different countries and food production in different years. So now look at this one now. See this Hong Kong. Hong Kong is still the highest in 2019, and also the highest in 2020. Wow. So as you can see now, Hong Kong had the highest food production in 2020 and 2019. So moving forward, you can see, let's check let's explore other years. So you can see that BFA BDI had the highest number of food production value. So compared to other years, and if you compare it to this other country here, let's check this one. So if you compare it to MLT, you see that BDI had the highest number of food production. But if you check BDI in these other years, you can see that they may not even have even had food at all, or maybe just minimal number of food production. So we're going over to 2017, checking the food. As you can see, it's like 2017, almost all the countries were able to produce enough food, unlike comparing it to 2020. So you can see that in 2018, a lot of countries produced a lot of food, because you can see the bars are quite very high. So I guess the reason why in 2020 they had a very minimal food production, it could be because of COVID or something. But if from the angle of having COVID in the picture, they should have a high number of food production. Anyway, maybe they could not go out to produce food or maybe harvest their food. So I guess I understand why in 2020 there was very low number of food production. Mind you, I got this data set from Cargo. So when you check moving forward, let's do another thing. Please, can you guys hear me? Hello, can you hear me?
Yes, we can.
Okay.
Yes, we can.
Okay, that's good. So checking 2016, you can see that each countries were very rich in food production. They had a very massive food production. Even BHR had the highest number of food production. So you can see that almost all the countries are top notch. They were, producing their own food and bringing out food supply. Food supply was in high number. So when you move forward, take 2015. So apparently 2020 had the lowest food production in all the countries. So you can see 2015. You can see 2015. You can see. Okay, I think I've checked this 2020, but let's run it again. So you see that the number of production was very low. Very low. Okay, I think at this point I added more data points. I think that's why the bars are very small. Okay. So at this point, I'm introducing a bus plot to show you how to identify outliers existing in your data set. Now I'm trying to identify this function. The reason for this function is to identify outliers in 1990 column. That's outliers. I already told you, they are data points that have very significant number of high values compared to the normal other data points. So at this point now, these things here are the outliers in 1990 column. So you can also, bus plot is the best plot to use and identify outliers existing in a column. So when you use scatter plot, you will see that quite number of outliers are existing. But I prefer bus plot because it gives you exactly what you're looking for. It significantly separates the main data points from the outliers. So at this point now, trying to so I'm trying to see the values in my in the 1990 column. This maximum number shows the highest number in the 1990 column, which is 136.7. So I'm trying to view all the values, all the data points under the column of 1990. So seeing that, okay, I'll be like, okay, how do I remove the outliers? So to remove the outliers, first of all, you check the mean of 1990, the mean value of 1990. So when you see it, we can see that it's 74.94 values. So at this point now, I'm going to name a function. I'm going to create a variable name, which is df2. So I want to say df2 equals to df, square brackets, df, square bracket, 1990, square bracket, close. So when I say I'm looking for all the values less than 150. So when I do that, then plotting the graph now, instead of putting the df, I had to put df2. Then when I run this, you will see that the art layers they have been gotten rid of, like they're no longer there, have eliminated all of them. So this is a way of removing your art layers. There are other methods too, but I had to use the simplest method so that you can be able to understand. So moving to 2020, I want to know the art layers. I want to remove the art layers in 2020 because I already have seen that, okay, 2020 column has art layers. Okay, how do I remove the art layers? So the same method I used. Okay, I'll now be like df2 equals to df square bracket df 2000. I'm looking for values less than 145. So when I run this, then I run mine. So you can see that the art layers have been removed. So when you move forward, let's compare this particular box plot to the time we had art layers. So you can see the art layer in this particular box plot graph. So if you check this side, you can see that the art layers have been, taken care of. So I told you guys I was going to show you a visualization that explains a pattern. So seeing my screen now, you can see that I've opened the Power BI. So I pulled the data to Power BI to create a better visualization. It's not like Python does not have good visualization, but when you come to Power BI, visualization is much more flexible. We can easily create things with different visualizations. So checking this. This is 2020 because you can see the way the food production went very low. Started from Hong Kong. Hong Kong had the highest food production. Then when you check this, United Arab Emirates had a very minimal food production in 2020. So apparently you can say United Arab maybe they were starving that period. Who knows what they were eating? So we can see Senegal had one of the second best in food production in 2020, followed by Mongolia, followed by Singapore, just like that. So if I actually do this for other years, I will not see how the food production went. So moving over to this other visualization. This looks very beautiful. It explains the food production in different years. So when you see this, you can see when you hover around, you see the highlights of all the years food production. So when you're looking at this, you will now see that St. Kitts and Nevis had the highest number of food production in all the years. Really? Wow, this is good. So when you look at it, you see that this particular country here took first in food production. Looking at Hong Kong came second. This is Fiji. This is Bulgaria. So this particular visualization explains everything. Besides Cyprus is Dominica. So you can see Spain. Spain had very minimal food production in all the years. You can see their sum of food production. So this is a table that I created to further show you number of production with different years. So you can just scroll further to see. So I don't know if any of you have any questions, because you can, bring it on. Hello, do you have any question? Hello?
Yeah, I can hear you. If they have any question, drop it in the chat.
So when you look at Namibia, see Namibia's food production, the total number of food production in 1990, compared to the total number of food production in 2000. When you look at for 2020, you see you see okay, hold on, let me check if I added 2020 to this. Okay, I didn't add 2020. Sorry guys, I didn't add 2020. So if you check Namibia food production in 2020 is 103. We compare it to the food production in 1990. It's quite different. So looking at this now, you can be able to compare different years, different countries' food production in different years, the amount of food they were able to produce in different years. I can see that it actually varies. The amount of food of production in 2020 is different from amount of food or food production in 2017, different from 2015, different from 2013, different from 2020. Different from 2012, 2000, and 1990. So this is what visualization helps you to do. It helps you to explain the patterns of each country's food production. You can say, okay, for the fact that almost all the countries did not produce any food in 2020, you can say, okay, it's because of so thing, because of COVID, because of this, because of that. And most times, if it wasn't because of COVID, if it wasn't because of COVID, maybe there was a particular reason why a country or maybe all the countries had very low food production. You can even give an advice by saying, okay, it was because of so thing. COVID is nature, and we could not. There's no how we would have even taken charge of that particular one. But there are some situations where it was as a result of human error that caused low food production. So you can even give an advice to your company or maybe to the country, okay, saying, okay, this was the exact thing we did that made us not to have high number of food production. Okay, let's change from this. Let's do this so that we can get a very high number of food production. And you can also compare how well your country did in past years. So you can now, bring all those former things you guys did in the past to have a better food production moving forward in future. Okay, someone is asking me a question. Yakubu Nabilat, sorry. Okay, why are you using less than 150 and 145 under how to remove outliers? So he's also asking, he or she is also asking, what's the difference between Tableau and Power BI? Well, Tableau and Power BI, they are all business intelligence tools. They do both, they can do same thing. They have same functions, and yes, they build visualization in the same way. So, but Power BI is one of the newest Microsoft software currently, but Tableau is quite old. It's been existing before Power BI. So I guess I've answered the question, because if you know Power BI, a lot of companies would like to work with you, because why? Power BI is one of the recent business intelligence tools. And I would say Power BI is very smart, even though it can be slow when you open it, but it's a very smart software. It's a very smart business intelligence tool. And besides, I love the functions in Power BI. Power BI functions are quite great. I've actually tried working with Tableau. I've tried creating measures, doing, I don't know if in Tableau, if you can create relationship in Tableau, but in Power BI, you can create amazing relationships that you never even thought of they exist. And when I mean creating a relationship, your company can give you two data sets and they don't correlate, and they want you to just figure out something, but you can create an invisible inactive relationship using a function. And this is very good, and it's so wow. And one thing about Power BI, when you are working with Power BI, you're automatically working with Excel somehow, because Power BI is a better version of Excel Power BI. Excel has Power BI, it has Power Pivot, and it has Power Query. So they just created Power BI to give a better version of Excel. So I don't know if I've answered your question. So moving forward to why I used this 150 less than 150 and 145. Let's go to Python. I'll explain why I did that. This is year 1990, right? So let's check the box plot of year 1990. So as you can see, yeah, this is year 1990. So as you can see here, the plot actually stopped at 50. So in order to remove the outliers, is either you say you want the numbers less or equal to 150. You want the data points with a value of less or equal to 150. This is a way of getting rid of these outliers. Because if I see I want a number less or equal to 400, the outliers will still be there. So that's why I used that format to remove the outliers, because somehow outliers makes your visualization look very funny and stupid. Because you call yourself a data scientist and you plot a graph and you are having these outliers there. Okay, you can have it there and you say, okay, I use the box plot to identify that outliers are existing, which is quite understandable. But when you're not presenting to the board, to the board of directors, sorry, when you're trying to present to them, you're not supposed to present your box plot having outliers. It doesn't look professional. I don't know if I've answered your question. So any other question? Yakubu, have I answered your question? Okay, I will say Power BI. Okay, which is more flexible, Tableau or Python? Python is flexible because you can do virtually everything in Python. You can do everything with Python. But Power BI, the reason why most times after building visualization in Python, I will still go to Power BI and build visualization because Power BI gives you an opportunity to express how you want to build your visualization. And it gives you an edge when it comes to data storytelling. It's good to either Power BI or Tableau. Can you use time series analysis to identify the trends in food production? Yes, sure. You can use time series analysis. How do you mean by time series analysis? Time series analysis is peculiar to neural network, but you can still do that. You can. It depends on your data set. If your data set is a time series data set, why not? And the data set is about food production, why not? You can. Is there any other question? Do you guys have any other question? So I will just give 5 more minutes for question. Okay, so in the absence of no question, I'd like to call it a day. Thank you so much for making our time to attend this live coding. And I want to apologize again for starting very late. Thank you so much.